Hello and welcome back. Now that we've had the opportunity to get some practice with remembering how order of operations, combining like terms, simplifying and evaluating expressions works, now we're going to go into those exponents and start getting into our rules that give us some nice shortcuts when we deal with exponents. So let's start with exponential form. And remember, exponential form is going to be a to some power of x, where a is our base, and x is our index or power or exponent. We can use those words interchangeably, remembering that the base is what's being multiplied and the power is how many times it's being multiplied out.
And now we go on to the properties of exponents. And all that says is that when we multiply two exponents with the same base, you add the powers. So for the example, you get a to the m times a to the n equals a to the m plus n.
And remember, we have m plus n not combined here because they're not like terms, but they will end up representing usually numbers in our examples, and you'll see what we mean, and then you will, if you can combine them, do so.
And then when we talk about division, when we divide two exponents with the same base, you're going to subtract the powers. So if I have a to the m power divided by a to the n, you got a to the m minus n.
And the third one is going to be our power of powers. And that means simply when you take a power to a power, you're going to multiply the powers. And I know power is written a lot in there, but these are the types of things you're going to see.
So in the first one, you've got a to the m parentheses to the n. So what you're going to do is you're going to take a and you're going to take m times n. So you're left with a to the mn power. And then the second one is a times b in parentheses to the n power. And basically what you're going to do is you're going to take the n and put it to the a and to the b. So you get a to the n times b to the n.
And you want to be careful there, because a lot of you are going to want to say that you distribute that n, because that's what you've used in the past. You need to be careful with that, because we're not really distributing it, because then it implies multiplication, because that's what the distributive property is, when in fact we're giving it to those.
So very similar for the division, we're going to do a to the n over b to the n. So you're basically sharing that exponent to a and b at this time.
Some of you might have already noticed at the bottom of the screen that I have PEMDAS written down. We're going to challenge you because we're missing something from that, so you need to make sure that you get that added into your notes. And then in class tomorrow, tell us what it is that's missing. Maybe we might have some sort of reward for you if you can tell us. But this is kind of a nice little trick to remembering how you're going to do and what you're going to do with each situation. But when you take the e, remember exponents, we're saying if you're taking an exponent to an exponent, or power of powers, that means you're going to multiply the powers. Likewise, when you are multiplying exponents, you're going to add the powers. And when you're dividing exponents, you're going to subtract the powers. I found that a really nice, neat, easy way to go about doing it so that way you don't forget. So let's take a look at some examples.
So if we look at example A, we've got d to the second times d to the fifth. So if we go back in our notes, we know that we're going to add those together. So we're going to get d to the 2 second power plus 5. And yes, we want you to write that out rather than combining it right away until we move on or until your team quizzes come up. So then we're going to have d to the 7th power. So then on part B, we have 5 to the 7th divided by 5 to the 4th. So we know that when we're dividing, we need to subtract our exponents. So we have 5 to the 7th over 5 to the 4th. So we're going to minus that. We're going to have 5 to the 7 minus 4, which then equals 5 to the 3rd.
And the question always comes up of, do we have to leave it that way or can we multiply it out? Well, I will take it either way, but you want to make sure you're careful because what happens if this was 5 to the 5th? You're starting to get some really big numbers really quickly. But if you want to say, I know that 5 to the 3rd is 125, then you can go ahead. I will take either one of these answers on quizzes, on tests, on standard checks, everything. Let's take a look at the next two. The next two deal with powers, so they're a little bit more challenging. We have for this first one, t to the 9th times t to the 6th, all to the 4th power. I want you to start with your parentheses first. So that means that I'm going to have t to the 9 plus 6 power, since it's multiplying, still to the 4th power. Well, 9 plus 6 is 15, so I have t to the 15th, all still the 4th power. Now, because it's a power to a power, I know that that means multiply. So I know I'm going to have t to the 15th times the 4th, which 15 times 4 is 60, so we have t to the 60th power. This last one, kind of a challenge. We see that we're dividing here, so we're going to subtract, so that means I have n to the 4 minus 7 power, still to the 3rd. And then I take 4 minus 7, so that's n to the negative 3rd to the 3rd power.
I didn't think we could have negative exponents.
You're right. So we'll start initially, this would be n to the negative 3 times 3, which would be n to the negative 9th. But we don't want that negative exponent. We want to have positive exponents. So I look at it in terms of, think of n as nickels. Class 1 has 4 nickels. Class 2 has 7 nickels, and they're having a contest to see who wins. Well, their 4 nickels cancels out 4 of their nickels, leaving us with n to the 3. Well, if you cancel out all of them, they have nothing, but we put a 1 because you can't put a 0. And then we have n to the 3rd left on the bottom, which is still being taken to the 3rd power. And like our rules showed before, you take that 3rd power and give it to everything. So n to the 3rd to the 3rd, which is really 1 to the 3rd is 1, and because it's 1 times 1 times 1. And n to the 3rd is n to the 3 times 3, which would really be 1 over n to the 9th. So this would be the correct answer we are looking for. So now that we've had some examples, we want you to go ahead and give these 3 you-try problems a shot. Go ahead and enter them into the Edpuzzle quiz questions just so we can see ahead of time what they look like. And bring your questions with you and your ideas for the summary to class tomorrow.